So today is day 6, chapter 10. Yesterday what we did is I introduced you with the way the Minitab output looks like and how to interpret the Minitab output. And today we're going to continue with that. Now today there's even more information given in the output than there was yesterday, and I want you to recognize it when you see it. Some of the things students do is they do manual computations on a test when they don't have to, and it takes them a lot longer, or they don't know how to do a problem. And if they just look a little closer, the output is right there on the test. So I want to point this out. And the figure below gives the Minitab output for the regression of natural gas consumed by the Sanchez household before installing solar panels. X is the number of days that they hit a certain degree, and Y is the amount of gas that was used for their household. Use this output to answer the following questions. Okay, this is in your packet. I believe it's page 10. Is that correct? Page 10? Okay, so the regression equation, I've whited that part out, and this is the Minitab output like we talked about before. We have the constant, which is the y-intercept, in the degree days, which we're calling x in this problem. This is my x variable. The coefficients are right here, the standard deviations are here, the t-ratios and the p-value. Based on this output, go ahead and write down the regression equation for this output, since I whited out the equation. Okay, so what you should have seen was that the regression equation is simply, this is the y-intercept, this is the slope. Don't forget the y-hat. You'll lose a point because it's a different y than y. Y by itself just means the observed y. Y-hat means the one that the regression equation predicted. So based on the output, this is where these numbers came from. The y-intercept is the coefficient of the constant, and the slope is the coefficient of the x variable, because degree days is considered my x variable. So I just wrote down these, and that's how I got this regression equation. Okay? The next question asks, in the month of January, after solar panels were installed, there were 40 degree days. So in other words, x equals 40. How much gas do you predict the Sanchez household would have used per day without solar panels? They actually used 7.5 cubic feet of gas per day. How much gas did they save by using solar panels? Go ahead and do problem B. Compare their actual with the predicted. Okay, so for this problem, basically you substitute 40 into the regression equation. So when I substitute 40 in, I got that they used 8.65 100 cubic feet of per day of gas consumption. Now they actually used, in reality, so the regression line predicted 8.65, but in reality they used 7.5. So the predicted amount minus the actual shows me how much they saved. They saved 1.15, so this is how much they saved. Okay, do you understand that? Okay, now the next question is asking you, here is the output from the prediction option in Minitab for 40 degree days. Give a 95% interval for the amount of gas used that would have been used this January without solar panels. Okay, look at question C carefully. It's really important when you're doing these problems to know what the variables represent. And sometimes when you're reading the equation, it's better just to write x and y right in the equation to help clarify what they're looking for. So in this case, they said, give a 95% confidence interval for the amount of gas. What's amount of gas represent in this problem? The amount of gas used, is that x or y? So the amount of gas used is my y value, right? That would have been used this January without solar panels. Okay, so the amount of gas used is my y value. So in this question, I'm asking you for a confidence interval for the y value, a 95% confidence interval for the y value, correct? Okay, when 40, the degree days, is my x value. So when x equals 40, I'm asking you to give me a confidence interval for y. So all I did was read the sentence, look for the names of the variables, and put x and y in their place, and then it kind of clarifies to me what I'm looking for in the problem. Now this is the output from Minitab. They want a 95% interval for the amount of gas used that would have been used this January without solar panels. From our formula sheet, we had two different types of intervals when we were talking about why. We had the mean and for an individual response. Which one is this one asking for? An individual for this January, right? For this January. So I wanted the individual response. So which value am I looking for? The prediction interval or the confidence interval? Prediction. This January refers to a prediction interval. Now, this is what I was telling you in the beginning of the class. A lot of kids get a question like this on a test. This printout is sitting right in front of them. And they look at the printout and they do all the computations. What they'll do is they're going to go to their formula sheet, and they'll go to chapter 11, and they think they have to do all the calculations, and they do this prediction interval, and they try to do these calculations, but they can't find all the numbers, and they don't know what to do. What I'm telling you is this question, sometimes the Minitab output is given to you. So all I'm looking for is for you to tell me this. The 95% prediction interval is 7.87 to 9.2. I'm 95% confident that the true amount of gas the Sanchez family would have used in January is between 7.87 and 9.2 if there were 40-degree days. Okay? All right. So that is what I wrote here for part C. I just asked you for the prediction interval. All you have to do is read it from the Minitab output. So sometimes it's not as hard as it looks. You got to look at what the interval, but it is important to interpret what the question is asking. You have to be able to look at the question, know which variable is X, which variable is Y, and then know how to read the printout. One other thing about this printout, let's go back down to this printout for a second. This is the confidence interval, so this is the mean response when X equals 40. This is the prediction interval, so this is the one response when X equals 40. The standard deviation of the fit, you see this number right here? This would be the standard error of mu of y hat. Okay, that's what that number is right there. Okay? All right, give a 95% confidence interval for the mean gas consumption per day in months with 40-degree days. Okay, D you should be able to answer pretty easily. Go ahead and do D. Okay, so for part D, I didn't have the recording on, so I got to redo it. So again, all I wanted was the confidence interval. The average value for y when x equals 40 is this. I'm 95% confident that the gas consumption for the Sanchez family on average is between these two numbers when the degree days equals 40. And again, notice that the confidence interval is smaller than the prediction interval because averages vary less than individual data points. Okay? So that's it. That's just reading. Sometimes it's as easy as that, but you have to be able to interpret it. Okay, the next problem on part E, right? I gave you part E. Give a 90% confidence interval for the slope of beta 1, the regression line. So I want you to do a 90% confidence interval for the slope. Now, think about it for a second. I'm talking about the slope. Am I talking about this output right here when I'm referring to the slope? Is this referring to the slope? No, this stuff down here is referring to the y value, right? I want a 90% confidence interval for the slope. So I go to my formula sheet. If I want a confidence interval for the slope, this is what I need. I need beta 1, I need t star, the degrees of freedom are n minus 2, and I need standard error beta 1. Now, in this particular output, I can find those values. All those values are given up here in this part of the output, but I need to know where to find them. So go ahead and give a 90% confidence interval for the slope beta 1 of the regression line. Go ahead and do that. Okay, so for this one, a 90% confidence interval for the slope. I wrote down the equation. I need to know what the slope and the standard error of the slope. So I go back to my output. Degree days is x, so the coefficient of x, this number here is my slope. The standard deviation of my x is the standard error of beta 1. So this number here, right here, is the standard error of beta 1. Those are the numbers I use for that computation. So everybody see where I get them from the Minitab. Okay? So then, based on that, I write the confidence interval. Now, T star. Okay, how did I know N for this problem? What did it say? I can't hear you. Okay, so where does it say? Oh, right there in front of my nose. N equals 30. Okay, so I got N equals 30, so I look up the degrees of freedom of N minus 2, so N minus 2 is 28. So I got this for a confidence interval. Now, in plain language, it means I'm 90% confident that the true population slope is between 0.18 and 0.2. Since 0 is not in the interval, the slope is not equal to 0, and temperature and the amount of gas used are correlated, or you could say they're linearly related. It's the same thing. Okay? So that's how I read the Minitab, interpret the Minitab, and write an analysis based on it. You can see the computations on this are real simple because most of the output is in Minitab. It's the interpretation that's important. Okay? Now what we're going to do is we're going to go to the next problem, and I want you to go ahead and do this one. This one's on Manatee. This is part of your homework, by the way. If you finish it in class, you won't have homework. It's 11 and 12. So basically, you have the powerboat registrations, number of manatees killed. They're in thousands, okay? And you're going to, I know we did this, but now I'm doing it with the Minitab output. So I want you to do all the way through F based on what we talked about. Remember a little bit about this. This part of the output up here refers to the slope. This whole line is talking about the slope. So this is beta 1 right here. This is standard error beta 1 right here. Okay? Then later on in this problem, they give you output right here, and this is talking about the y values, the confidence interval and the prediction interval for the y values. You need this. This is the standard error of mu of y hat. You're going to say, oh, I need to calculate that in order to get a certain value in this, because the last question on this part asks you for a confidence interval to give a 90% confidence interval instead of a 95. See where it says 10.10 at the very end? It asks you to do a 90% confidence interval instead of a 95%. In order to do that, this number is standard error mu y hat. You need that because the formula sheet shows you standard error mu hat. You need that for the confidence interval. In order, you need that number. And so T star will change, but the standard error mu hat is right there. So I want you to go ahead, complete that problem, and then it'll be homework. So I'll check it over for homework, okay? So you should know how to read the output now. If you have questions, ask me. And then we'll go over it on Monday. Okay? Questions?